Some places don't kill you, they rewrite you. You are looking at Saturn's rings, the most beautiful structure in the solar system, a silver halo that makes people forget to breathe. But you are not here to look. You are here to cross them, and the closer you get, the more you realize the truth. Those rings are not soft. They are not gentle. They are a shredder built out of ice, moving faster than your instincts can understand. So tell me, when the universe offers you beauty, how often is it a warning?
In the next few minutes, you are going to learn why Saturn's rings are dangerous in ways your brain was never designed to imagine, why gaps are not empty, why dust can behave like gunfire, why the ring plane is not a flat sheet, but a living field of wakes, waves, and charged ghosts, and why, if you listen closely enough, the rings can sound like weather, even in a vacuum. This is not clickbait. This is orbital mechanics and consequences. Because out here, the rules do not bend to your feelings. They only bend to mass, speed, and distance. And one mistake, and the universe stops behaving.
You are strapped into a seat that was never meant to be comfortable, only survivable. Your craft is small by interplanetary standards. A hardened survey skiff with a forward shield, redundant comms, and a navigation brain that never sleeps unless you tell it to. Outside the viewport, Saturn fills everything. Bands of pale gold and ash, storms like bruises, and below it all, the thin line of the ring plane. It looks like a single stroke of light. It is not. The plan is simple on paper. A fast transit through a sparse region, a brief ring plane crossing, then you drop into a safer corridor to rendezvous with a drifting instrument package that went silent last week. You will be in the ring environment for minutes, not hours. Minutes are supposed to be safe. Your systems begin reading the environment long before you arrive. A subtle rise in charged dust. A static taste in the air filters that should not have a taste. A faint rasp in the radio, like someone dragging sand across glass. You check the log. The noise has no source and no pattern you recognize. Then the first impacts begin. Not hard, not catastrophic. Just tiny ticks against the forward shield, irregular, like sleet. Your mind hates it, because your mind knows what sleet is, and it knows you are not supposed to hear it here. You remember something an old mission specialist once said about a deep ring crossing years ago. That the instruments recorded thousands upon thousands of micro-impacts in moments. And when they converted it to audio, it sounded like hail on a thin roof. A joke back then, a novelty. Now it is your soundtrack. And the rings ahead still look beautiful. Like they do not care.
You cross the outer edge. At first, nothing dramatic happens. No explosion. No shockwave. Just a faint tremor in the hull. Like distant rain on a roof you cannot see. And then your sensors begin to map the real ring. Not a sheet. A traffic system. The inner ring particles move faster than the ones farther out. That difference matters. Because when streams slide past each other, they do not do it gently. They do it with shear, with grinding, with endless, patient collisions that turn edges into powder. You hear it as a rhythm. Tick, tick, tick. A tapping that speeds up as you descend closer to the densest bands. Microhook. If the ring can tap your hull, what else can it touch? Your telemetry shows small impacts, then more. A rise in temperature along the forward plating, not from fire, but from abrasion. Saturn's rings are made mostly of water ice. That sounds soft, almost innocent. But ice at orbital speed is not soft. It is ceramic. It is shrapnel. You try to picture it. A single grain of icy sand moving around Saturn at something like 16 to 20 kilometers per second, depending on where it is in the system. Relative speed is not always that high, but in the wrong geometry, in the wrong crossing, it does not have to be. One mistake, and the universe stops behaving. Your first clear turn happens when the probe's camera resolves individual pieces. The rings stop being smooth. They become a blizzard of hard points. A cloud of bright flecks that do not drift like snow, they orbit like knives. Then you see something worse. A dark gap that looks like a safe lane. You aim for it. But the gap is not empty. It's just less crowded. You slip into it, and the impacts drop to a whisper. Your breathing slows. And that's when the transmission changes. You were tracking a repeating pulse, a narrow band signal buried under ring noise. Now it gets louder. Not because the source is closer, but because the ring itself is helping it travel. This is a hypothesis, but a plausible one. Charged particles in Saturn's environment can interact with the magnetic field, creating pathways that guide dust and plasma. Under the right conditions, a noisy environment can become a carrier. Like a wire made of ice and electricity. The signal begins to ride the hiss. And the hiss begins to sound like structure. Microhook. Are you hearing a message, or are you hearing the rings interpreting you? You push deeper. Now the rings are no longer just a hazard. They are dynamic architecture. You pass through regions where sunlight skims the plane and throws shadows. In some seasons, those shadows reveal towering clumps and vertical structure, features that should not look alive but somehow do. Cassini even saw temperatures in parts of the rings plunge to about -230 degrees Celsius during equinox conditions. Cold enough to make everything brittle. Cold enough to preserve edges like blades. You see faint radial markings, ghost lines that appear and fade. Spokes. Transient features that scientists think are tied to tiny icy particles lifted by electrostatic charge, lasting only hours. They look like fingerprints. And when the spokes form, your signal spikes. As if the rings are opening and closing a circuit. Second clear turn. The rings are not just shredding objects. They are exchanging material, trading it, moving it. Moons steal particles, other moons donate them. Some embedded objects carve propellers, disturbances that stretch for huge distances, made by moonlets roughly a kilometer across. You are not alone in the ring plane. There are things in here that do not announce themselves until you are close. Your proximity alarm chirps once. Then again. A mass anomaly. The camera shows nothing at first. Then your LiDAR paints a shape. Not a moon. Not big enough, just a lump. A chunk of ice and rock, irregular, tumbling slightly, hidden in the glare. It's moving in the same direction you are, almost the same speed. Almost. Micro-hook. If almost is the difference, what does contact look like at orbital scale? You fire lateral jets, a gentle correction. The impacts surge. Your craft is drifted into a denser lane. Now the hull noise is a roar. The hiss becomes a grinding scream, like a saw cutting through frozen bone. And the transmission breaks through clearly for the first time. A voice-like pattern. Not words yet, but cadence. 3 pulses, pause. 2 pulses, pause. 1 long pulse. It repeats. You listen, and you realize it matches your own beacon sequence. The signal is not calling you. It is mirroring you.
Your comms pick up a new signal, a low, steady tone beneath the static. It is not a voice. It is not a message. It is a carrier wave, stretched thin, as if the ring environment itself is feeding your antenna something raw. You recall the data briefings you skimmed and half forgot. During close passes, probes have had to shield themselves, literally turning their own antenna into a forward-facing armor, because even tiny ring grains at high speed can cripple a spacecraft. The memory is clinical. Your reality is not. The particle flux climbs again. The sound becomes harder. Your comms pick up a new signal. A low, steady tone beneath the static. It is not a voice. It is not a message. It is a carrier wave, stretched thin, as if the ring environment itself is feeding your antenna something raw. You recall the data briefings you skimmed and half forgot. During close passes, probes have had to shield themselves, literally turning their own antenna into a forward-facing armor, because even tiny ring grains at high speed can cripple a spacecraft. The memory is clinical. Your reality is not. The particle flux climbs again. The sound becomes harder, sharper. You feel it in your teeth. Then, without warning, the forward shield light drops by 1%, then 2, then 5. Not from a single hit, from abrasion, from cumulative violence, a sandblaster made of ice. You are inside the shredder now. You cannot see individual particles. You can only see what they do. The way light scatters in front of you as if the void has become fog.
The way your outer thermal coating begins to haze. The way your star tracker loses lock, then regains it again because dust is climbing above the plane. Your navigation brain offers options: slow, change angle, abort. But every option costs something. Slowing down means more exposure time. Changing angle means more relative collision speed. Aborting means turning through an environment that punishes turning. So you choose the only thing you can. You commit to the corridor you have, and you make your body very still, as if movement could somehow change physics. A brighter streak flashes across the forward camera. Not a meteor, a chunk of ring ice, larger than the grains, larger enough to be seen because it is catching sunlight. It does not hit you. It passes close enough that your hull vibrates anyway. You realize something that makes your mouth go dry. The ring plane is thin, but not uniformly thin. There are places where material piles and clumps, then stretches apart again. A dynamic architecture of density, a constantly shifting maze. And your maps are never perfectly current. No map can be. Your forward shield shudders, a new alarm. Microfracture detected. Containment holding for now. You are seconds from ring plane crossing. This is the point where you cut through the sheet, where the physics of lanes and wakes becomes a wall you must pass through. The shredder's mouth. Your craft angles the forward shield into the flow. You feel the impacts intensify like a storm front. Tick becomes rattle. Rattle becomes roar. A sound you should not be hearing, yet you are. Through vibration, through structure, through the translation of violence into sensation. You clench your jaw. You stare at the timer. 3, 2, 1. And then it happens. For a breath, the forward view turns white with scattered light. Your shield takes the brunt, but the whole craft rings like a struck bell. The radio tone spikes. The static becomes a scream. Not emotional, electrical. Your outer coating sheds particles of its own. You are now adding debris to Saturn's rings, feeding the shredder with pieces of yourself. You punch the comms to record everything, because if you do not make it out, the only thing you can leave behind is sound. And in that sound, buried beneath impact and noise, you swear you hear rhythm. Not random, not mechanical, like a pulse. This is a hypothesis, but one possibility is that the ring environment is acting like a vast electromagnetic instrument, charged dust moving along fields, coupling to the planet, feeding currents you cannot see. If that is true, then you are not just being sanded down, you are being measured, sampled, read. The shredder is not mindless, it is a system, and systems have signatures. The flux begins to drop, the impacts soften, your star tracker locks again. You are through. But your hands do not stop shaking because you know what you brought with you.
You drift into a darker corridor where Saturn's bulk blocks the sun. The rings behind you vanish into shadow. And for a moment, the universe looks empty again. You run a hull integrity scan. The numbers are not catastrophic, but they are worse than you expected. Your forward shield is etched like frosted glass. Your outer surface has lost material. Your sensors are dusted with grains that will not easily discharge. You tell yourself you survived. You tell yourself the worst part is over. Then you play back the comms recording. At first, it is what you expect. Impact noise. Static. The low carrier tone you could not identify. But halfway through the crossing, the tone changes. It modulates in a slow pattern.
Not like speech, like spacing, like a code that does not care if you understand it. You compare it to the ship's own systems. No match. You compare it to Saturn's known radio environment. No clean match. The simplest explanation is interference. Charge and dust and motion coupling into your antenna, producing a phantom signal. That should comfort you. It does not, because the pattern repeats. Exactly. With the same intervals. As if the rings wanted to be heard the same way twice. You stare at Saturn through the forward viewport. You remember how the rings looked from far away, like a painting. And now you know what they are up close. Not a halo, not jewelry. A grinding machine that can throw material into the planet. A downpour of ring matter falling along magnetic paths, feeding Saturn's upper atmosphere with a chemical cocktail and dust. Beauty that is actively decaying. You approach the drifting instrument package, the reason you came. It is tumbling slowly, scarred, silent. And when you dock and pull its data core into your cabin, you find something that should not be there. A thin frosting on the casing. Icy grit. Ring dust. It followed you. You wipe it with a cloth. The cloth crackles with static. And the radio, even when muted, feels like it is still speaking.
Here is the last truth. The one you will carry longer than any scar on your hull. Saturn's rings are not beautiful because they are safe. They are beautiful because they are extreme, because they balance on the edge between collapse and order, between clumping into moons and grinding into dust. From far away, you see symmetry. Up close, you see violence, the kind that never gets tired, never gets angry, never stops. And if you ever feel tempted to call them peaceful, remember the sound. Remember the hail you were never supposed to hear. Remember that a spacecraft once had to hide behind its own antenna just to pass near them, because even a smoke-sized grain can end a mission. Science you can hear, dread you can feel. So now I ask you, if you heard it, would you answer?